Our talk is supposed to start by 10, but there's a breakfast slash food frenzy happening right now. So we are asking our volunteers to kind of get everybody into the rooms as the talks are starting. So we'll just wait for another 2 minutes before the talk starts. Thank you so much for being patient with us.
Should I use the mic or no? No, I don't like want to hold it because I talk like this a lot, like this. I have this for the video, I think, but I can use it, and I can also like yell. Yeah, true. True, yeah. It's not that big of a room, so. Yeah, cat Leo, yeah, exactly.
Hey everyone, a very good morning to you all. I'm Gyan and I'm the Leadership Fellow for Blockchain and Women in Code. And I would love to welcome you all to Connect Asia today. So this is our first talk for the day. This is Training Room 11, also known as Track 3. So all of the tracks that we have today, you can just check at the desk or you can also look at your agenda and come here. Today I would like to introduce our speaker, Kat. Kat Liu is a senior software engineer at N26, and today she'll talk to how we can launch a. So I would let Kat take over.
Cool.
A round of applause for all our speakers. So I think that we're gonna set as a rule. An applause before to encourage them and an applause later as well for the awesome job that they've done.
All right.
Let's see if you want to need the
Yeah.
mic. Let me just.
Can you hear me like this, or is it better if I use the mic? I feel like it's probably. Yeah. Okay. That's fair. Okay. Hello. What? That's not on. Uh-oh. Off to a good start here.
Yeah.
Ah, there we go. Hello? Hello? Okay. Cool. So, good morning, everyone. Thank you so much for coming. I'm super excited to kick off a full day of really great talks with really great women and men. I think there's a couple men as well. So before I get started, I just want to give a quick thank you to Women Who Code and anyone who was involved in making the event happen. This is my first Women Who Code event, actually, and it's gone super smoothly so far. Everything's gone really well. Yeah, and thank you everyone for coming as well. Thanks for spending your Saturday here. It's like very impressive. You're not even using this as like an excuse to skip work, so you must really care about the content, so that's really nice. And yeah, today I'll be talking to you about how N26 went from being just a pan-European company to launching in the US, and how it's all the product and technical decisions that we took to position ourselves as kind of a global company. The quick agenda. I would be super surprised if anyone here even knew who N26 was, so I'll give a brief introduction to them. I'll do a little bit of talking about the infrastructure and architecture, and then we'll launch into the problem set of the day, which is how do we actually launch an existing product in the US? What are the requirements? We'll iterate through some solutions and then go over the implementation details of said solutions, and then finish off with some lessons learned. So I think I have to like hold this really close to my face actually also. Okay, so who is N26? N26 is Europe's first online-only consumer retail bank. We were founded in 2013, so it was kind of at the beginning of this like wave of challenger banks, neobanks, these banks that don't have any brick and mortar branches, only online. So when you sign up, you can first sign up in like 8 minutes. You get a fully fledged, fully regulated bank account with a debit card. You also, with N26, you get shared accounts, sub-accounts. You can apply for a credit, and investment, insurance, premium cards, so on and so forth. On top of your typical banking features, we also kind of overlay a bunch of very modern features to help you manage your financial life. So things like spending statistics every month, real-time notifications on card transactions and incoming transactions. And we also have a lot of seamless security features built in. So you can enable and disable the card straight from the app, and you can also have two-factor authentication on outgoing transfers. Some numbers, so I started actually in 2016. We were about 150 employees. We had 150,000 customers total. We had barely launched in 5 countries, and we only offered a Euro account. And technically speaking, we had 1 monolith and like 1.5 microservices. Fast forward to 2019, they're now over 1,400 employees. They're coming up to about 3.8 to 4 million customers. They've actually launched in 26 countries all throughout the Eurozone and including the US and UK. So as a result, you can open an account in euros, pounds, or dollars. We've managed to break down that monolith into 90 plus microservices, and as of July 2019, we were the highest valued fintech in the EU. Unfortunately, I'm actually no longer at N26 anymore, but I mean, to say that they really glowed up is definitely an understatement, and it was definitely one of like the most challenging, rewarding, and fast-paced experiences of my career. What is my role in all of this? So I was a senior software engineer there for over 3 years. I'm originally from the US, but I moved to Berlin a little bit over 4 years ago. And in 2017, I was sent to New York City by N26 to help open up the New York office, help hire, and like kind of get the conversation going about how to actually launch in the US. And then I came back and I led the authentication team, so managing all like your user credentials, session management, third-party applications, so on and so forth. We ended up actually implementing the solution I'm going to talk about today. And so, yeah, talking about technical interests, I'm very interested in distributed systems, making sure that those distributed systems are reliable and scalable in production, and security. So very back-end heavy, really like not a full stack or front end at all. Okay, cool. So let's get into the more interesting stuff. Because N26 is relatively young, only 5 or 6 years old, we can take advantage of quite a modern tech stack. AWS, we don't host any in-house servers or anything. All of our backend and data services are all Dockerized. All of these containers are managed and orchestrated by Nomad. We also use Consul for service discovery, Vault for secret keeping, and the 3 of these kind of tie together our microservice ecosystem. We also use Terraform for all of our infrastructure as code provisioning. And we also like to practice continuous deployment, and that's facilitated by Jenkins. And because we expect every merge to go live automatically, we obviously rely very heavily on automated tests, and we use Karate for that. And we also use like Gatling for load testing and some other front-end tests too. But like I said, I don't know that I'm not a front-end person. This is a very quick look at our deployment pipeline. So you merge a PR, and the first thing we do is build your artifact and run your isolated tests. And then it gets deployed to our development environment. So the dev environment is completely open to devs. They can play with it however they want to. Then we run a test suite, and then we'll push it to staging. So staging is actually closed and audited for QA for testing. So this is actually a banking requirement. And then we run the test suite yet again. And then provided that goes well, we will then deploy it to live. And live is obviously closed and audited, only available to a select like on-call engineers and only accessible for incidents. So like I mentioned, we have over 90 domain-specific microservices. All of them have at least an HTTP interface. Most of them also have some kind of async interface, so they talk to a stream or a queue for async processing. And they were all previously, while we were still just a European bank, hosted on the EU Central Availability Zone. And this point will become pertinent in just a little bit. So let's say it's 2017, our CEO, Valentin Stelf, had said, you know what, I think N26 is such a great product, we should launch it in the US. And I think, yeah, banks in the US are horrible, let's launch there. And that was basically as specific as a requirement got. So we had two people, like the US CEO and myself, shipped off to New York City, and from there we really had to start from a very, very like high level and think about, okay, what would a banking product, retail banking product look like in the US? So if you are considering taking an existing product and bringing it to a new market and thinking about what features you need, I would say your feature set falls into one of two categories. The first one is region-specific features. So these are things that are local to the market, and these are things that you can't bring from your existing product. You have to build them specifically for this market. In the context of banking, this would be like your bank payment schemes. So in Europe, we have SEPA, which is it's basically how you get money from account A to account B. And while the behavior is exactly the same, you can't, the rules are completely different, the codes, you can't take what we have in Europe and bring it to the US, right? So you have to build ACH, which is the batch payments in the US. Similarly, because the US is a completely different legal landscape, there are also a lot of integrations that need to exist only in the US, yeah? So banking partners, card processors, fraud partners, these are all very US specific. And if you're not building something region specific, then you're building something region agnostic, and these are your shared features. So these are things that actually are the same from your existing product to your new product. And these things on a very high level are things like authentication and authorization. So the way that your users log into the app is basically the same globally, yeah? So it's always a username and a password, maybe like a biometric, yeah. The transactions view and model is also relatively the same. So if you think about what a transaction looks like, it does not really vary that much from country to country or region to region. You have like an amount, you have a settlement date, you have like a merchant, country, so on and so forth. So these are pretty standardized. And then we can also just bring over features that we want globally as well. So things like card settings, yeah, being able to enable, disable the card from the app, setting limits, so on and so forth. So this kind of relationship between your region-specific features and versus your region-agnostic features, this actually tells a lot about your business. And I call this ratio the feature divergence ratio. I came up with that. It's like not an official thing, so don't search it or anything. You're not going to find anything. And it's also like really not supposed to be taken as a rigorous technical definition. It's really just kind of to get the conversation going about, okay, how different do we want this new product in this new market to be? So it's really not a very precise science. I would say it's like the least precise of this presentation. But it's going to become very important though when it comes to like architectural decisions. So let's talk about architecture a little bit. This is obviously a very simplified of the architecture. We have a user service, which is in charge of user data, authentication service, storing your tokens. And then this is an example of what a transaction look like. So we have the SEPA specific service, which is connected to Bundesbank, which is like the German central bank. This is a general banking thing, yeah, so like several times a day, we send out transactions to them and then fetch them from them as well. And then store them in like a generic transactions service, which holds all kinds of transactions and is basically used to query a user's balance at any point in time. About like the bare minimum amount of work that we would need to do to launch in the US. Well, we've already done all this work to kind of separate out into several microservices. So you can just kind of think that, okay, the US launch is just like another transaction type, and everything is just like a new feature, right? So you just apply a simple little proxy pattern here, where the proxy is in charge of deciding whether or not it's an EU or a US transaction. The US transaction talks to the partner bank instead of Bundesbank. And yeah, like that's pretty much it, right? You apply this pattern a few more times wherever you have some slight differences. Everything is hosted out of EU Central. And yeah, I mean, estimate like a 6 to 8 month implementation timeline. Gave it to the CEO. It was like the best news I'd ever given the CEO ever. And then I actually like drew this out and invited like all the upper management people to a meeting, and yeah, presented it. The only mistake I made was like I invited the legal department to this meeting, and I don't know if the legal department how they are in your company, but at N26, like they're obviously very competent, but it seems like all they say is just like, no, sorry, it's not going to work. That's illegal. You know, we're going to get fined millions of euros and lose our banking license if you do this. Blah blah blah. Like minor details, you know. So yeah, thanks to them, like the actual legal requirements started to come in afterwards. So requirement number 1 is that US and EU user data has to be stored within the boundaries of their respective legal countries. So okay, we need like US user data to be stored in the US and EU data to be stored in the EU. So previously we had just the EU Central 1 data center. Now we need to build something out in the US as well. So obviously, this increases complexity by a lot. We have like a whole new set of infrastructure to deploy, you know, VPCs to set up, security groups, like IAM roles, deployment pipelines. I'm not going to get into the details of those just yet, so let's just pretend like they exist already, and then move on to the actual architecture. But not only that, now we have actually a lot more options and choices to make when it comes to how we're actually going to do this US launch. So option 1 is to start from scratch. So this is actually like you have a US specific mobile app, you have a US specific backend, and there's complete isolation between these 2 data centers given. That's pretty much out of the box. So our legal department really liked this option because, again, it's very difficult for any kind of like cross-contamination of requests. So this was what that would look like. A US app that points to api.n26.us, because US is a lot cheaper than the .com domain. And then on the other side, we have an EU-specific mobile app, and this stays pointing to the .de domain. So anytime a user downloads an EU app, they can only hit the .de domain. Option 2 is obviously to reuse and recycle what we have, and this could also apply to you as well. So what does this look like? There's a it's one app for the entire app store. There's also a shared backend infrastructure where we deploy shared services to both regions, and like region-specific ones to their respective region. So here, isolation is still possible, but a little bit harder to achieve. Yeah. And if you're a technical person, this probably sounds like a better option, because I mean that's kind of like a foundation of computer science, is to be able to reuse and recycle as often as possible. And so what would this look like? Now you have a .com domain, and this is shared within the app. And what happens is the .com is actually geolocated DNS resolved. So if you are physically closer to the US, it will resolve to the .us domain. If you are physically closer to the EU, the .com will resolve to the .de domain. So in most cases, you have almost the same thing. And so what is the right answer? So you have like your legal department claiming to do one thing, your technical department claiming to do another thing. But the right answer actually depends on neither of these. It actually depends on that feature divergence ratio. And why is that? So option one, to start from scratch, is actually a better option if you intend for these businesses to be rather different. So if you want less dependencies between each other and you want your US business to kind of like run off and do its own thing, like maybe we don't even want to launch a retail banking product there, maybe you want to do like only credit cards or only like SMB businesses or something like that. And there's a higher differentiation of market specific features. So there's not much to share between the US and the EU. Then why would they share the same infrastructure, right? You want to enable them to move as quickly as possible on their own. So this is typically better for globally divergent businesses. And there's like companies like, well, I don't know if I should say this, but like Unilever, which is kind of like a global product, but have very local specific markets, and these operations kind of run very independently. So your FDR is a little like greater than 0.5-ish. Mm-hmm. Yeah. Mm-hmm. Yeah. Yeah. So actually the rest of the talk is about actually users who travel and like what happens there. But to answer your question on like a legal basis, this is very banking specific, but like you're supposed to legally only have a bank account open where you have a legal address. So if you do move from the US to EU, you are supposed to kind of like cancel it and then open it again if you want to stay within the bank. But yeah, that's technically the answer there. So option two for reusing is more suitable for companies that have a more are going for a more centralized kind of globally managed global management. So where you're leveraging core competencies and only slightly varying your feature set for specific markets. And again, it's better for globally convergent businesses. So like Uber, Facebook, these kinds of companies, their app is more or less the same, their product is more or less the same between countries. So where does N26 lie on this spectrum? So actually in 2017, they changed their slogan to building a bank the world loves to use. And the following is a quote from our CFO, which is, our US launch is the next logical step for N26 to be a global bank. Indeed, there are many people around the world looking for a simple, hassle-free way of banking. So these two, while US is the next logical step, made it very clear that eventually they kind of want like data centers on all continents, like hundreds of countries, 100 million users, all by like 2022, so on and so forth. And also, if you've ever had a bank account in more than one country, like what are the features that you use of a bank account? They're basically, you have a debit or a credit card, you have the account itself where you can make transfers, you have overdraft, savings, invest, credit loans. Like these things don't vary that much from country to country. So given all these things, given all these concerns, it's better to reuse and recycle in our case. So let's dive a little bit deeper into the architectural part of things. Let's say, we already have our services deployed to both regions, and now we have a US user, Bob at n26.com, who wants to log into the app. So Bob is like living in the US right now. The first request, usually whenever you have an app, is to get a token, log in with your username and password. And so the app makes a call to .com, it resolves to .us, and the auth service is able to find Bob at n26.com. And then usually the second call after that, you get a token, and you make a call to like fetch your user data in that case. So this is, relatively simple. So we do market ourselves as kind of a bank for like a great travel companion, great for expats, great for like digital nomads. So it's perfectly reasonable. It's a perfectly good use case for Bob to travel to the EU one day and decide, and like open up his app. So what happens at this point? He makes a call to log in, and it resolves to .de, and the auth service there says, I don't know who BobN26.com is. Now there's a couple things that could happen here. The first being like, okay, the authentication service could say, okay, I know it's not in the EU, but I know I have a like twin sister in the US. I'm going to make the call to the US service. And at that point, the service would find Bob and then return. And then the same thing happens for the user's call. So this will work. This will work in all cases. It's obviously not architecturally that sound, and why is that? Because now every single business logic service that you've built is aware of the existence of another data center. So this is knowledge that needs to be baked into every single team. And sure, you can kind of extract this out to like a common library or something, but the fact of the matter is that whenever you create a new service, we need to be aware that, okay, yes, there is another data center, and if it's not found here, we have to propagate the call. A slightly better version of this, so same thing happens here, but instead of the authentication service calling the other data center, we actually will return to the gateway, and the gateway will actually do the routing on our behalf. So we'll return like a 404, like a user not found. The gateway will know to take that and then propagate to the other data center. And again, the same thing happens for the users. So we miss it, and it will return, and the gateway will call the other data center. So this is obviously a little bit better because now the only service that is aware of data centers is the gateway, and it's within the responsibility of a gateway to actually do routing. So this is slightly better. But it's also still not great. And why is it not great? Because the app made 2 requests. And those 2 requests ended up with 4 requests to our backend, right? 2 of which were erroneous. And so if we launch like this, first of all, the error rate is going to go up, right? Because now we have requests coming from multiple data centers looking for users. And now it becomes a lot harder to tell whether or not this increased error rate is due to a programmer error, or like maybe people are just traveling more this time, right? So this is not very good for monitoring or observability. But still, for as like a minimum viable product, we said this will work. Let's just see if this can happen. So again, we brought this up to our legal department, and they said, no, I don't think so. So the second requirement comes in, and it's that requests that contain sensitive user data are subject to the data processing requirements of that region. And I said, what does that mean? And then he says, well, basically, requests that contain sensitive user data cannot bounce from data center to data center. And I think this is probably a bigger deal for the EU than it is for the US. Because you can imagine if an EU user logs in and then it hits the US data center and like they log like a phone number or an email or something, and then somehow you have a directive to turn over your server logs, and now like the government has has EU user data. And also during the time of the GDPR thing, a lot of US websites just denied access to any EU customers, saying, sorry, we cannot serve you anymore because we can't guarantee that your data is going to be securely stored. So it can't, that's another reason why they don't want requests to bounce from data center to data center. So it's back to the drawing. Oh, sorry. So that's actually I was kind of glad to hear this also, because given the issues of this architecture, we knew that was less than perfect, and for once, legal requirements actually kind of aligned with technical best practices. Also because with 2 data centers, it's relatively manageable because, okay, it's not in the EU, so okay, it must be in the US, check that data center. But as we mentioned, we want to launch globally, and so what happens if Bob tries to log in and we don't find it? we say, okay, like who knows who Bob@n26.com is? You know, we can like broadcast the message to n data centers, and so now one request has become n requests. We're like flooding our data centers with requests, and only one of which will return actually Bob. This is actually also not great from a security standpoint, because if you imagine that you're under attack, like someone's attacking you with like a rainbow table and just hitting your API with emails and passwords and DDoSing you, now you've actually increased the surface area of the attack from one data center to your entire like global network. So instead of just bringing down one data center, this attacker's managed to bring down like your entire global infrastructure. So in that sense, and this kind of exponential fan out is something that you should be at least cognizant of whenever you have partitioned data sets. So it was like a little bit back to the drawing board. How do we actually do this in a way that is compliant and also architecturally sound? So you have to think about why are we going from one request to n requests? What is it that is making that why is this a requirement on a technical level? And if you're familiar with like databases and partitioning, we effectively have horizontally partitioned databases, yeah? So where there's a US shard and an EU shard. So the schemas of these two are totally the same, but it just holds a subset of the users. And the partition key here would be the email, and that's how we know where the data sits. Typically, in a situation where you have sharded databases, this is actually just given by the ID. So the ID, let's say you have 4 clusters, the ID mod 4, you know, you get anything from 0 to 3, and then there it tells you exactly what shard to go to. So you don't have to query every single one. It's actually given in the ID. But in this case, our ID is the user email, right? The user email is like chosen by the user, and there's nothing in the email that suggests that, oh, this is a US user, this is an EU user. We can't know that. Like, we can't look at bob@n26.com and determine from there which data center he is in. But how can we do this mapping? How can we take the email and map it to a specific data center? Well, it's actually a pretty data structure to do that. So what if we have a new global service that kind of maintains a global table? So it holds username, Bob, and then the respective data center. And so this happens for all users. And yeah, this is like a new service inside the gateway. And so what happens now is the app makes a request. The gateway finds bob@n26.com and knows that, oh, okay, we're in the US data center, so it's going to route the request directly to the US data center. So it doesn't touch any of the insides of the EU data center. And the same thing happens for the users as well. Yeah, it makes a call to the gateway looks up the user, and then routes the request to the correct data center. So this actually gets around requirement 2, because nothing is processed actually within the actual data center itself. But if you remember requirement 1, now this kind of is a violation of that, right? Because now we have these emails, which are obviously personally identifiable, stored within the data centers. Oh, so also this global table, like I could honestly give a whole nother talk about this in and of itself, but I'm going to gloss over it very quickly. So there's one that sits with the US, one that sits in the EU, and it's like a master replicated like NoSQL table. So every single time you write to the EU, it will eventually propagate to the US, and that's how we end up with like basically 2 tables of the entire list of users. Yeah, there's a lot to say on that, but unfortunately we don't have time for that. So yeah, back to, we're violating requirement number 1, but what is the difference between this solution and the original solution we had? Is this. is actually just like the sheer volume of data, right? So in here, everything about the US users were stored in the EU. So login information, transaction history, user profiles, everything. Here we have literally one line, which is the email that we need of the user. So it's much more manageable at this point to say, okay, let's just apply a one-way hash to the username, like a one-way like secure hash, yeah. So instead of knowing exactly it's bob@n26.com, we know it's some string, and it's a unique string for every single email, but we don't know who it is. So what would that look like? Roughly the same thing. And the great thing is that the app can actually put in the request header. It can actually apply the same hash that we use in the table, put it in the request header, and now we don't know exactly who's logging in to what data center, and we never know anything about Bob himself. We only know this hashed string. And another great thing about this about this architecture is that we've actually not changed any requests, any existing requests. We've only added on like one extra header. Nothing about fetching the token has changed. Nothing about fetching the users has changed, except for this one header that the gateway uses. So no other business logic service uses this. Let's do one more optimization. So this data center is relatively static information. Actually, you can make the argument that it's the most static. It's the entire, sits the entire life cycle of the user, and never changes. And so we shouldn't have to make the same request every single time, right? So once we've made one request, we can actually return in the response the actually correct data center. And front end can actually store this in a local store. And then for every subsequent request, it goes straight to the US data center and does not have to touch the EU at all. So the only time that there's a possibility of the user hitting the wrong data center is like the first time the user logs in on a specific app. So we gave this to the lawyers, and the lawyers were very happy. The engineers are happy because they get to work on their, they get to build a good architecture and reuse what they want. Region-specific teams are happy because they can build like the ACH service and not care about what's going on in the EU. And region-agnostic teams are also very happy because now when they build a product, it doesn't just launch in the EU, it launches globally and everywhere and has much more reach to users. So this is actually the solution that we went with. This is running in production, and as of June, I think, the US launch for N26 is live, and there's been no issues so far, at least with the login portion. I can't really speak for anything else. Cool. It's already been like 40 minutes, okay. So lessons learned. First thing is always check with your legal department, because any solution you implement, it would be really sad if your legal department says, actually, like this will bring us down completely. So that's very important. Second thing is that your business strategy and product decisions come first, and only from there do your technical decisions happen. So just technical decisions, there's no like purely right or wrong technical decision, right? There's always a context with it. And on a technical level, either you make more requests or take up more space, right? We saw this when we decided to use the table instead of kind of fan out to all the requests. And this is like a very fundamental concept of computing with limited resources, like generally speaking. This is the reason we do like database indexing. This is the reason why we do caching. This is something that is applicable to like literally every single time you think about building anything. And the second thing is, whenever you do build a new feature, make sure to minimize the impact to its smallest unit. So we made one service aware of the data center. We stored one identifier per user in the other data center, and we limited it to one possible request that hits an incorrect data center. So this again is like something you'll also read in any kind of clean code, clean architecture book. It's also relatively fundamental. And so really the lesson learned here is to apply your fundamentals to everything. So even they're especially important when it comes to like building something as complex as a US bank, right? This is the most important thing. And yeah, that's pretty much it. So yeah, if you're an EU, US, or UK user, please check out N26. It's a very pretty app. You get a pretty card. If you're not, then I don't know. Stay tuned, I guess. It's coming, so but I just don't know when. Yeah. Any questions? That's it. Yep. The architecture, it was probably like three to 4 weeks actually, because this was like pretty much all we were doing. And when we had all the requirements of all the other banks, basically only just for like how do we make login region agnostic, right? So this is the kind of iteration we did there. It was not like 3 weeks for the entire infrastructure. It was just particularly this portion. Mm-hmm. Yeah, so front end will actually hash for us. So actually, like when we write, we always make sure that the user is already in the correct data center before writing to the table. So when the user signs up, we hash it there, and then afterwards we hash it on front end. So nothing after that actually touches back end. No, this is a persisted table. This is a persisted table. It's not in memory. So there's like, yeah, I mean, this can also, you can shard it yourself because it has like millions of rows. But yeah, it's not stored in memory. It's actually. If you look at this concept, like this thing, this can also be, security measure. Anyone can hack this table. Yeah, sure. On top of that, how you are maintaining the security on this table? So obviously it's like within the VPC, these endpoints are not public. There's no way for any outsider to actually touch the table. On top of that, if it is leaked, which is why we did it, like there's not much information that an attacker can garner from this, right? It's just some hashed strings. They don't know who the users are and the respective data center. Mm-hmm.
So I'm interested how the discussions with the legal team go because usually legal people are not very technical.
It's a good question. Like they pushed really, really hard for like completely separate apps and completely separate backends. They pushed really hard for that. Convince them, like I don't know, our legal department knew what like hashing was, and so they knew like okay, if it's hashed, it's not personally identifiable. It was mostly like the tech team driving it and then going to lawyers saying this and then like getting their feedback and then iterating over it and like telling them actually this is fine. So I'm not saying you should like defy your lawyers or anything, but it should be the technical team kind of driving the discussion because it's easier for them to come up with the solution than like legal. It's like legal should not be coming up with the solution, I would say. They just set the requirements and then it's up to the tech team to kind of fit the architecture into the requirements. Cool. Is that it? Yeah, sure.
I was just wondering, like, after you implemented this whole thing, like, do you do any efforts in like improving or increasing observability, or like, what are the issues that came up and stuff like that?
So yeah, so because this is like a master replicated table, there's always a scenario where you can write to both data centers at once, and then you'll have a collision, yeah, because it's eventually consistent. And I mean, there are different ways that you can get around that. So one of them being we write only to the EU and then have it propagate to the US. So that is one option if it's allowed. This is like not really allowed in our scenario. Another thing is we will actually just raise an alert when this happens, because it depends, like, so what does it mean if we have a collision, right? It's very unlikely for a user to sign up in the EU and then like before it's been propagated, it like runs over to the US and tries to sign up also. So when this does happen, we know that it's like a misuse of our API. It's a user who is specifically hitting both at the same time. So, and because the only thing that he can affect is his or her own account, we will just raise an alert when there is a collision, and then we'll take care of it manually, probably like by closing both accounts or notifying the user. So that was something that we definitely had to take into account and had to have monitoring for as well. Yep.
One question, how do you handle the blank slate when a user sign up on the app itself? Then
Yeah.
that exists in the table, correct?
Yes, so that's true. So there's already, there's a lot of like front-end logic in the app itself. So it's like they pull up the country-specific terms and conditions, for example. So a US user is defined as someone with a legal address in the US and same in the EU. So when you sign up, the first thing you do is give your address, and then front-end will actually know, okay, it's US or EU. We obviously also do a check on back-end as well to ensure that, okay, the address is actually in the country itself. But yeah, that's how we do that.
So
Yep.
with regards to the sign up, so the address is like region specific
Mhm.
information as well. So do you do something like this for the address also?
No, because once we get the address, we just we extend it off to the correct data center. So anytime you have like the country is the US, we will explicitly send it to the US.
So the front end handles it.
Yeah. And if you are hitting our back end, well, that's also like a misuse of our API too. If you're hitting it directly there and trying to sign up, we just consider that to be like a normal bad request error. So we won't save it in that case.
So if a user is moving from one country to another, the address can be changed because it could be
Mhm.
like a scenario that digital nomads. So
Yeah.
how do you plan it? Like how do you check the address over there? So you try to focus it on the address checking.
Yeah.
The primary thing.
So it's like not in the MVP per se, it's like to be able to like move accounts, because it's also not just the address, like you have to change from a Euro account to a US account. And you could also you could keep it is like that. I don't know if I should say that, but so like what do we do about it? Yeah, I mean, we have mechanisms to close an account, obviously. So if a user does call and says, I'm moving, I want to open another account, there's a manual process to close it, and then the user can sign up again, either using the same email or a different email. And then as long as they pass all of the correct KYC, so KYC stands for Know Your Customer. It's like when you sign up and give your tax ID or something, we make sure it is who you are. So as long as they pass that, we consider them to be legitimate users with accounts.
Okay, guys. So if you have any more questions, Kat's gonna be here around, and you can catch her during lunch or any of the other breaks, and
Mhm.
to just bombard her with a lot of questions. We want to set up.
Sure.
I'd like to close the talk now.
Cool.
Thank you so much, Kat, for.
Thank you so much.
Yeah. Guys, bravo.